Very good afternoon, students. Good afternoon to all of you. Good afternoon, JNB Minicoy students. Can you able to hear my voice? Am I audible and visible? Just let me know your answer in the poll which I have launched.
No.
Can you able to see me? Am I not audible? Am I audible now?
Sound കേൾക്കണില്ല.
Am I audible now? Students, can you able to hear my voice? Am I audible now?
No, madam.
Let me know the answer in the chat box. Can you able to hear my voice now? Okay. So fine, let's go into the topic. So we are discussing about the thermodynamics, right? And we have completed the basics of thermodynamics and some of the thermochemistry part of the thermodynamics and the first law of thermodynamics we have done. And in the last class, we have completed the Hess law and the thermochemical equations. Okay. So today we are going to. Is my voice very low? Not audible? Just give me a second. Can you able to hear my voice now? Is it okay?
Yes, madam.
Yes?
Yes, madam.
Okay. Great. Happy to see the JNB Minicoy students over here. Good evening, Bhargav.
Good evening, madam.
Okay. So fine. So let's go into the today's topic. So today we are going to look into the spontaneity. Okay. So in this topic, we are going to cover the spontaneity, what is meant by spontaneity and what is entropy, then entropy versus spontaneity, second law of thermodynamics, and lastly, Gibbs free energy and spontaneity. Okay. So this will be the last main topic of this lesson. So once we complete this, we can go through some previous year's questions of this lesson, and then we can go to the next lesson. Okay. So coming to the spontaneity. So what is a spontaneous process first of all? So do you have any idea about the spontaneous process? Can you tell me what is a spontaneous process or what is the meaning of spontaneous? Have you heard of the term spontaneous before? Has anyone heard the term spontaneous before anywhere? Sudden action. Okay. So Bhargav was saying it is a sudden action. Okay, fine. So now I'll tell you the process which does not need any help of external agency to occur is called as spontaneous process. Okay. So I'll give you one example so that you can understand. So here in this example, you see, I have two objects, object A and object B. Object A is a hot object and object B is a cold object. Okay. So if I bring these two objects closer to each other and if I make them touch each other, what will happen? Can you tell me what will happen? If I bring these two objects closer to each other and make them touch over each other, what will happen?
It will combine.
What will happen to the system? What will happen to these two objects? What will happen? One is a hot object and the other one is cold object, right? What will happen if we keep these two objects together? There will be some heat
Transfer of
flow.
energy.
Sorry? Yes, Anupriya?
Transfer of energy, ma'am.
Very good, very good. Very good, Anupriya. So there will be the heat flow. There will be the heat flow, the transfer of heat energy from hotter object to colder object, right? So what I have done, I have just brought those two objects together. That's it. Automatically, the heat energy is getting transferred from object A to object B. So this process does not need any external agency help. It has just flowed on its own. Okay, so this is one example for spontaneous process. Spontaneous means continuous. Continuously, it will take place. The reaction will take place on its own. So that is called a spontaneous process. And one more example is here. The water flows down the hill. So water is just flowing down the hill on its own. So we are not making the water to come down, right? It will just flow from above to below. So the spontaneous reactions are the continuous process in which it can happen on its own. Okay. But if you want to reverse back, if you want to reverse back the spontaneous reaction, you need to have some help of the external agency. Okay. The spontaneous reactions cannot be reversed without the help of external agency. There is some need of external energy for the spontaneous reaction to be reversed. Okay, clear? So this is all about the spontaneous process. I hope the definition and the meaning for spontaneous process is clear to all of you who are watching here. Any doubt from this? Or anyone? Shall we go for the next? So now I'll go for the enthalpy versus spontaneity. Okay. Every system tries to reduce its energy in order to gain the stability. So we all know this relation, right? Stability is inversely proportional to energy. Stability is inversely proportional to energy. So if the system is in lower energy, then it means that it is more stable in nature. Okay. If the energy of the system is very less, then it means the stability is very high. Okay. So every system tries to keep themselves in its lowest energy state to attain the stability. So this is the very important concept which we are studying in the entire chemistry, especially in chemical bonding. You might have studied that two atoms will come closer to each other and they will form the bond to attain the stability by lowering the energy. Okay, so this is a case and this is a fact which applies to all the cases. Got it? So now let's go into the new topic which is called as entropy. Okay, entropy is denoted by the letter S. So what is entropy? What is the definition for entropy or what is the meaning for entropy? So it is the measure of degree of disorderness or randomness in a system. Okay. So what is entropy? It is a measure of degree of disorderness or randomness in a system. Okay. So first of all, I will take one system. Okay. This is one system. So here the blue colored that balls are the atoms. Okay, let us take those are as atoms. And all the atoms are arranged in a regular manner, regular pattern. Okay, so all of them are arranged in a more ordered way. Okay, so here the randomness is very less. Okay, since it is more ordered, the disorderness is very less. Okay, since entropy is directly proportional to the disorderness, entropy is nothing but disorderness, right? If the disorderness is more, then the entropy will be more. If the disorderness is less, entropy will be less. They are directly proportional. Since the orderness is more and the disorderness is very less, the entropy will be very less for the system. Okay. And next I will take one system in which the atoms are little bit far away from each other. Okay. And here the entropy is medium. And in the third case, if you see, they are very far away from each other. The atoms are very far away from each other, means the randomness is more, right? If the randomness is more, then the entropy is also more. Or I can say that the orderly arrangement is very less. Okay, so that the entropy becomes more. I can take the first case as solid, second case as liquid, third case as gas. So in case of solid, the atoms will be arranged in a regular pattern. In case of liquid, there will be some space. But in case of gas, all the molecules or the atoms will be very far away from each other. Right? So what do you understand from this? In case of gas, the entropy is more. Okay? The entropy of the gas is more compared to the entropy of the liquid compared to the entropy of the solid. All right. So what is entropy? Entropy means the measure of degree of the randomness or disorderness in a system. Clear for all of you? Any doubt? Do any of you have any doubt from this? Bhargav, Anupriya, JNV Minikoy, Naveen Kumar, Jnanashree, Roshan, Kirti. Any doubt? Okay. Okay, fine. Very good. Sanjana, Tanuja, Vangto, and Yamperni, right? Okay. So now let's go into some points about this entropy. Let's study some properties of entropy. Okay. So first of all, entropy is a state function. What is meant by state function? Do you remember? In the first class, in the basics of thermodynamics, I have taught, right? We have studied two functions. One is state function and the other one is path function. So can you tell me the definition for state function? Any of you want to type? Want to give the definition for state function? What is a state function?
Ma'am,
Yes,
depending
very
upon
good, very
initial
good.
and final
So
state.
the one which depends only on the initial state and the final state. Very good, Tanuja and Minikoi students. Yeah, which does not depend on the path. Yes, Roshan. So, which does not depend on the path. It depends only on the initial state and the final state. So, those functions are called as state functions and entropy is one among those. Okay. So, now as I have already said, the entropy of the gas will be more. So, the change in entropy, the delta S of the gas will be more compared to the liquid, compared to the solid. This point is very important. Okay. And the third point is it is an extensive property. What is meant by extensive? We also have studied about extensive property and intensive property. So what is meant by extensive property? Do you remember the definition for extensive property? Can you give me the definition? Yeah, Roshan, it does not depend only on the mass, which depends on the quantity. Okay, not only mass, some other quantity. Okay, but very good. Your answer is correct only. Roshan and Tanuja, very good. So the property whose value changes on changing the size of the system, changing the quantity of the system are called as extensive property. Okay, so the entropy is the extensive property. Now, one more formula we are going to study. If I want to find out the change in entropy of the reaction, that is delta S naught R, okay, I have to do the summation of delta S naught of product minus summation of delta S naught of the reactant. Got it? So already we have studied 2 to 3 formulas similar to this formula, right? So this is the next formula. To find out the change in entropy of the reaction, you need to do product minus reactant. Product minus reactant. Okay. So all the 4 points which is there on this slide are very, very important. Please note down. If you have done this, if you're done with this slide, just let me know. I will go for one question. We will solve it together. So are you all done with this? Shall we go for the question? Say yes or no.
Yes, madam.
Done. Very good. All of you have done it, no? Now we'll go for the question. Yes. Thank you so much for the students who are giving me the reply. So I want all of you to take part in the class. So try to involve, okay? So here is the question. The question is saying that the predict in which of the following entropy increases or decreases. So we have 4 statements or the reactions we can say. So in each case, you have to tell me whether the entropy is increasing or it is getting decreased. What about the first case? First case is saying that a liquid is crystallizing into solid. Naveen Kumar is saying that in the first case, entropy decreases. What about others? Are you all agreeing with the Naveen Kumar's answer? Yam Parmi is saying that it will increase. What about others? Sanjana and Rojan are going for decrease. Other students? Will it decrease or it will increase? Majority of you are going for decrease. Decrease. Bhargav decrease. Minikoi is also saying decreasing. Okay. Let's see the answer. A liquid is getting converted to solid. Mahalakshmi is also going for decrease. Yes. All of your answers are correct. The entropy order is solid lesser than liquid lesser than gas. Means entropy of the gas is more. So if the liquid is getting converted to solid, if the liquid is getting crystallized into solid, we are going from liquid to solid. We are going towards the left. So what will happen? The entropy will decrease. Okay, because the randomness will decrease. So the entropy will decrease. Very good. What about the second case, students? The temperature of crystalline solid raised from 0 Kelvin to 115 Kelvin. What about this case? The temperature of crystalline solid raised from 0 Kelvin to 115. Will it increase? Why it increases? Can you give me the explanation that why it is increasing? Why in the second case the entropy increases? What is the reason? If the temperature increases, entropy will increase. Is that what you mean? So molecule gap increases because temperature increases. Move to solid to liquid. Yeah, all of you are trying to give me the correct answer. It is all of your answers are partially correct. It is correct only. Okay. So what will happen? What will happen if the temperature is raised from 0 Kelvin to 115 Kelvin? Suppose, let me take a container. Okay. So here I have some crystalline solid molecules. Okay. So if I give the heat, if I increase the temperature, so all the particles, all the solid particles will move far away from each other. Will move far away from each other. Okay. So there will be more movement for all the molecules. The molecular motion will be more. Okay. If they try to move very far away from each other, randomnesses will increase and the entropy will also increase. Okay. So what is happening here? If the temperature is raised, more molecular motion happens, and because of that, randomness will be more. So entropy is also more. Okay. Entropy increases. In the second case, for the second case, entropy increases. What about the third case? What about the third question? Will it increase or it will decrease? It will increase. Why? Why? Very good. But why it increases? Solid is getting converted to gas. Very good. In the reactant side, we have only solid. But in the product side, we have one solid and two gases. So we have more number of gaseous molecules in the product side. So ultimately, we can say that solid is getting converted to a gas. Solid is getting converted to gas. So entropy increases. Entropy increases. Very good. So what about the fourth case? What about the fourth case? What about the fourth case? Hydrogen molecule is getting converted to hydrogen atom. What about this case? Will the entropy increase or it will decrease? Will it increase or it will decrease? Yes, very good. It will increase. Why? Both of them are gases only, no? Then why it is increased? Why you guys are saying it will increase? Increases, correct answer only, but why? Very good. So in the first reactant, we have only one gaseous system. Here we have only one gaseous molecule. But here we have two particles. So if the number of particles increases, if the number of particles increases, it can be an atom, it can be a molecule, it can be an ion, anything it can be. But if the number of particles increases, randomness will increase. Okay, randomness will increase. So the entropy will also increase and the change in entropy will also increase. Okay, so here the number of particles is going from 1 to 2. So we have more gaseous molecules or atoms in the product side, which leads to the increase in the entropy. Okay, so I hope the question is clear to all of you. So now all of you can able to find out the answer, right? If they ask you the question in terms of reaction or in terms of statement type, all of you can do, right? Do any of you have any doubt? Is everything clear? Is this concept confusing for anyone? Okay, very good. So now we'll go for the next concept, which is called as entropy analysis. Okay, entropy analysis. So the entropy is getting analyzed using two factors. One is using enthalpy or heat. Okay, one is using enthalpy or the heat, and the other one is using the temperature. So enthalpy is denoted by the letter H or delta H we can take. And heat means it is Q. So we can use delta H or we can use Q. And T is denoted by the letter, temperature is denoted by the letter T. Okay. So what is entropy? Delta S. Delta S is calculated using the Q and the T. Okay. So now combining all these two factors, okay, from which the entropy is getting determined, we are arriving at one formula, which is delta S is equal to Q divided by T. So this REV is called as a reversible process. Okay, heat exchanged in the reversible process divided by temperature. Instead of delta S, if we want to find out ds, if we want to write ds, it will be equal to dq divided by t. What is the difference between delta S and ds? Delta S means large change in entropy, and ds means small change in entropy. ds means small change in entropy. Okay, otherwise both of them are same only. So this is a very important formula you have to note down in your notebook. Okay, now if I want to find out the total entropy change of the universe, which is delta S universe, it will be equal to delta S of the system plus delta S of the surrounding. Delta S of the system and delta S of the surrounding. Why we should be take only Q reversible? Because it is dependent only on Q and T, right? So all the entropy, those things can be applicable only for reversible system, my dear students, not for irreversible. Okay. It is applicable only for reversible process. That's why we are writing it as Q reversible. All right, Naveen Kumar. Okay. Yeah. So to find out the change in entropy of the universe, you have to sum up the system and the surrounding change in entropy. Got it? So now let's go into the next topic, which is called as the second law of thermodynamics in terms of entropy versus spontaneity. Okay. So I have two systems. One is gas A and the other one is gas B. If I mix gas A and gas B, so I will get a mixture like this, right? So what is the difference between the initial state and the final state? Initially, the randomness is very less. Okay, because I have only one type of atom in one container. But if I mix those two gases together, what is happening now? The container space is also increased and the randomness is also increased. All the molecules are moving here and there in a very random manner. Okay. So now the second law of thermodynamics says that the entropy of the universe increases. So this mixture is called as the universe. Mixture is called as the universe. So the entropy of the universe increases because the randomness of the universe increases. Okay, so how we can write this? Delta S of the universe as greater than 0. If the value is increasing, then we have to write that delta S of the universe is greater than 0. Okay. So this is what you have to use for the second law of thermodynamics. According to second law of thermodynamics, entropy of the universe increases, which means delta S is greater than 0. Okay. Now, the entropy for different process, we have two processes, right? One is reversible and the other one is irreversible. So we are going to find out the delta S of the universe. Okay, delta S of the universe for two different processes. For reversible case, it is equal to 0. Here I have taken delta S of the universe. In the previous case, that is different. Delta S is equal to Q by T. That is different. Okay, and delta S of universe is different. Okay, don't get confused there with the normal delta S and with the delta S of universe. Okay. So here we have two processes. For reversible, it is equal to 0. And for irreversible, it is greater than 0. Okay. So all of you take down these points in your notebook. Now we will go for solving one question based on this concept. Just let me know if you are done with it. Shall I go for the question, students? Are you all ready? Shall we solve? Shall we solve it together? So I hope all of you are having your notebook and pen with you. Yes? Okay. Calculate the entropy change for vaporization of liquid water to steam at 100 degrees Celsius. Given that heat of vaporization is 40.8 kilojoule per mole. So what is given? Heat of vaporization is given. Heat of vaporization is given. It means the Q value or the delta H value of vaporization. It is given as 40.8 kilojoule per mole. Okay, we have to convert this kilojoule to joule. We have to find out the entropy change, means we have to find out the delta S. This is entropy change of vaporization. This is what we have to find out. Okay, and the temperature is given as 100 degrees Celsius. So now, how to approach this? How to find out the delta S from the T and the Q value given? Which formula you will apply here? We have to apply delta S is equal to Q by T formula, right? Delta S is equal to Q by T formula we have to use here. So now the phase is changing. So if the phase is changing, then I have to write delta S of vaporization, which is equal to delta H of vaporization by T, right? So now the temperature is 100 degrees Celsius, but we have to solve the question in terms of Kelvin. So to convert 100 degrees Celsius to Kelvin, what we have to do? You have to add this with the number 273. So it will be 373 Kelvin. So the temperature is equal to 373 Kelvin, and the delta H of vaporization in the question, it was given as 40.8 kilojoule. So in terms of joule, what we have to do? We have to multiply this by 10 to the power 3. If I multiply this by 10 to the power 3, I will get 40,800, right? 40,800 joule per mole. 40,800 joule per mole. So these are the values now. 373 and 40,800 joule per mole. So we have to take these two values and substitute here in this equation. So if we substitute, what we will get? We will get 109.38 joule per Kelvin. Okay. So it is a direct substitution. Delta H and T. Both the values are given in the question. We are just going to take that and substitute in the formula. But the thing is, you need to do the conversion. Okay. You should not just substitute the temperature value which is given in the question as such in terms of degree Celsius. You have to convert that to Kelvin, and for delta H also, you need to look into the unit very carefully. Okay, in the question, if they have given in terms of kilojoule, you have to convert that into joule, and then only you have to solve the question. Is it clear for all of you? Otherwise, it is going to be very easy. It is just a division, right? Direct substitution and division, that's all. Only thing is you have to do the conversion and do the division. All right, is it clear? Is it easy for all of you? Do you have any doubts from this in the conversion factor or in solving the problem? Do you have any doubt in solving this problem or taking down the taking out the given values? Is there any doubt for anyone? No. What about others?
No, ma'am.
No, ma'am. Okay. Okay. Okay, students. Now let's go into the next topic, which is Gibbs free energy. Okay. So before moving on to the informations about Gibbs free energy, we should know why this term Gibbs free energy has come, right? So why it is coming in the spontaneity process, so in the spontaneity concept. So we all know that spontaneity is determined by the temperature and the enthalpy and with the entropy, right? Spontaneity is calculated using these three terms: delta S of the universe, delta H of the system, and the temperature of the system. T and delta H can be determined. Okay. If delta H or T is not given to you, how will you find out the delta S? The calculation of delta S becomes difficult if delta H or temperature is not given. So to make the calculation easy, a new term called Gibbs free energy has come. Okay, which is represented by the letter G. And this Gibbs free energy is also one of the property of the system. Okay. It also has one formula, which is G is equal to H minus Ts, where H is the enthalpy, T is the temperature, and S is the entropy. So here all three terms are involved in this equation, right? Entropy, enthalpy, and temperature. All the three are involved in this Gibbs free energy equation. Okay. So now it becomes very easy to calculate all the terms. And Gibbs free energy is a state function. You all know the property which depends only on the initial state and final state. So it is also a state function and it is also an extensive property. So if I change the quantity, the property Gibbs free energy will also change. Okay. And also we have one formula to find out the change in Gibbs free energy of a reaction. You need to do product minus reactant. Like in case of entropy, we have to do the same thing. Product minus react, summation of change in Gibbs free energy of product minus summation of the change in the Gibbs free energy of the reactant. Okay. So this is all about the properties of Gibbs free energy. Do you have any doubts from this? Now in the next slide, we will go for the Gibbs equation. The Gibbs equation from this formula. Okay, all of you remember this formula. G is equal to H minus Ts. Okay, we have studied 5 points here. So take down all the 5 points which is given in this slide. Now using this equation, we are going to see the Gibbs equation, which is going to be very easy only. Okay, there is no big derivation at all. It is just an easy thing. Let me go for that. So, we know that G is equal to H minus Ts, right? Like entropy and enthalpy, Gibbs free energy cannot be calculated easily. Okay, G cannot be calculated. Only delta G can be calculated. So for that, what they are doing? They are taking the change in enthalpy, and since the temperature of any system is going to be very constant, so it is written as such T. It is not written as delta T, and entropy cannot be calculated directly. Only the change in entropy can be calculated, right? So delta G is equal to delta H minus T delta S. So this equation is called as Gibbs equation, which is very, very, very important for solving the problems. Okay, for solving the numericals, this equation is very important. Is it clear now for all of you? This is the very last topic in the Gibbs free energy topic is the very last topic of this lesson. And this equation is one of the very important equation. Okay. Now, using this equation, for spontaneous process, what will be the value for delta G? How it is going to be? Let us see that. So for spontaneous process, delta G will be less than 0. Okay. If delta G is equal to 0, then the process is said to be in equilibrium. If delta G is greater than 0, then we can say that it is a non-spontaneous process. Okay. So this tabular column is again an important thing. So if a process has to be spontaneous, then delta G should be less than 0. What is meant by less than 0? It should be negative. Delta G should be negative. For equilibrium, it should be equal to 0. For non-spontaneous process, delta G value will be positive. Okay, all of you should remember this. For a spontaneous process, delta G value should be negative. Okay, if it is positive, then it is non-spontaneous. Please don't forget this. All of you try to keep this point in your mind. Okay, because this will be very useful for you in many of the physical chemistry lessons. Okay, clear? So now we will go ahead with one more tabular column. Now, here I have delta H, delta S, minus T delta S, and the whole thing, the delta G equation. And we are going to see whether the process is spontaneous or not. Spontaneity. If the delta H is positive and the delta S is negative, what will be the sign of T delta S? Can anyone tell me? If the delta H is positive and delta S, if it is negative, what will be the value of minus T delta S? Will it be positive or negative? Minus into minus. Yes. Very good. Minus into minus will be plus, right? So minus T delta S will be positive. Okay. So if this whole thing is going to be positive, and already we know that delta H is also positive. So now what will be the value for delta G? What will be the value for delta G? So plus and plus. Positive into positive is plus. Positive, right? Yeah. So the delta G value is also plus. Very good. Delta G value is also plus. Now, just now we have seen that delta G will be positive for which process? Very good, Tanuja. It is for non-spontaneous process. So this is the case for non-spontaneous process. Okay. So now let's go for one more combination. What happens if delta H is negative and delta S is positive? So now here minus into plus. What is minus into plus? It is minus, right? Yeah. So minus delta S will be minus. And already this is minus. This one is also negative now. So minus into minus is minus. So delta G is also negative. So if delta G is negative, process is spontaneous. Processes spontaneous. Okay. So what about the third case? Both of them are negative. If both of them are negative, minus delta TS value will be positive. Okay. Minus T delta S value will be positive and delta H is negative. So in this case, we have two cases. One is delta G can be plus or it can be minus. So when the delta G will be minus, when the temperature is very low, when the T value becomes very low, then delta G value will be negative. If it is negative, then the process is spontaneous. Okay. Now, if the temperature is very high, for high temperature, what will happen? The delta G value will be positive and the reaction becomes non-spontaneous. Okay. So this is the third point you have to keep in mind. Now coming to the fourth point. If both of them are positive, delta S is also positive, delta H is also positive. So what will be the value for T delta S? Minus T delta S. Minus into plus is minus, right? So minus T delta S will be negative. Minus T delta S will be, this term is negative. And delta H is positive. So here also we have two situations. Delta G can be plus or it can be minus. At low temperature, it will be non-spontaneous, and at high temperature, it will be spontaneous. So keep in mind that if the reaction is spontaneous, then the delta G value will be negative. Okay, in the third case, it is spontaneous at low temperature, and in the fourth case, it is spontaneous at high temperature. Got it? If these two terms are negative, then at low temperature it is spontaneous. If the delta H and delta S are positive, then the reaction is spontaneous at high temperature. Okay? It is very easy. This tabular column will be given to you in your book at the end of this lesson. Just go through that, or you can take down this from the slide also. Okay? So is it clear? Shall we go ahead with one question? So we have studied two tabular columns in this topic with the help of this equation. So just take down this equation and the two tabular columns which we have discussed. Shall we go ahead with one question? Are you all ready? Are you all ready? Shall we find out? Yeah. Here is the question. Above what temperature the following process would not be spontaneous? Above what temperature the following process would not be spontaneous? So what is the process actually? We have a particle A in gaseous state and it is getting converted to liquid. Okay. And for this process, delta S is given in terms of joule per Kelvin and delta H is given in terms of kilojoule per mole. Okay. Kilojoule per mole. So how to find out above what temperature the following process would not be spontaneous? Would not be spontaneous means they are talking about the non-spontaneous process, right? So we know that for non-spontaneous process, delta G value will be greater than 0. It means delta G should be positive, right? So we have to check whether the delta G is coming out to be positive or not. So how to approach this? For a non-spontaneous process, delta G has to be greater than 0, and from the relation delta G is equal to delta H minus T delta S, if the left hand side has to be greater than 0, then the right hand side also has to be greater than 0. Okay. So if delta G is greater than 0, delta H minus delta Ts should also be greater than 0. So I am writing like this. And now we are going to substitute all the given information in the question, in the formula. Okay. So let me substitute the value of delta H. What it is? Minus 20 kilojoule. You have to convert this to joule. So you have to multiply by 10 to the power 3 to convert this to joule. So it will be minus 20,000, right? Minus 20,000 joule per mole, which is the value for delta H. And temperature only we are going to find out above at what temperature the reaction is going to be non-spontaneous. So that is the question. So we are going to find out the T value and delta S is also given. Just substitute it. So if you substitute, this is delta H minus T delta S, which is greater than 0. So minus into minus becomes plus here. Okay. And in the next step, we are bringing this plus 50 to the other side. And it becomes minus 50 into T and minus 20,000 divided by minus 50 is less than t. So here the sign will change. Here the sign will change because I am bringing this minus 50 to the other side, right? So the sign will change. So now minus minus will get cancelled with each other. And now if I solve this, I will get 400. Okay. So if the temperature is above 400, then the reaction will be non-spontaneous. Is it clear for all of you? Any doubt from this? Any doubt from this? If the temperature is above 400 Kelvin, then the reaction will be non-spontaneous. Any doubt for anyone? Students? From this problem? Is everything clear? Okay. Now we will go for the very last topic of this lesson, which is Gibbs free energy and equilibrium constant. Okay, let me go ahead very fast. It is very easy only. So let me take a reaction. A moles of A is in equilibrium with B moles of B. So small a and b are the stoichiometric coefficient. Capital A and B are the reactant and product. Okay. For this reaction, the delta G can be written as delta G naught plus RT into logarithmic function of Q, L and Q, where R is the universal gas constant, T is the temperature, and Q is the reaction quotient. So what is reaction quotient? It is equal to, Q is equal to the product, concentration of the product raised to the stoichiometric coefficient to the concentration of the reactant raised to its stoichiometric coefficient. So this is nothing but the reaction quotient. Okay. So whatever be the product, you just write it in the numerator and put the stoichiometric coefficient in the superscript and put the reactant in the denominator and write the stoichiometric coefficient to the superscript of it. Okay, to the power of it. So this becomes the reaction quotient. Now, at equilibrium condition, what will happen, you know, the delta G will be equal to 0 because that is what we have studied in the one of the previous tabular column, right? Delta G will be equal to 0 for equilibrium process. It will be less than 0 for spontaneous. It will be greater than 0 for non-spontaneous. It will be equal to 0 for equilibrium. So at equilibrium, delta G will be equal to 0. Okay. And this reaction quotient is called as equilibrium constant. Reaction quotient can be written as equilibrium constant, which is KEQ. Okay. Now substitute these two values in this equation. So it will become like this. 0 is equal to delta G naught plus RT ln KEQ. In place of Q, we have written the equilibrium constant. Okay. So now you rearrange this. Bring this plus RT ln KEQ to the other side. It will become as minus RT ln KEQ. Now to convert this ln to log, we have to multiply by the number 2.303. Okay. So I have converted this ln to log by multiplying by 2.303 number. Got it? So this is the final relation, final equation, okay, which we are learning from this concept. And it is very important for solving the problems. And this is the formula which relates the Gibbs free energy and the equilibrium constant. Okay. This is the formula which relates the Gibbs free energy and the equilibrium constant. This is the very last formula of this lesson. Okay. So shall I take 2 more minutes to complete this lesson. Are you all available? So I just want to solve one question based on this concept. That's it. Shall I take 2 to 3 more minutes for that? Okay, let's do the question together and finish it off very fast. Okay. So this is the question. So all of you please try to do. The equilibrium constant for a reaction was found to be 10 to the power. It is the question, my dear. RT is not negative. The entire thing is negative. The entire right hand side is written in the minus form. Okay, because we are bringing RT, L and KEQ to the other side, no? So the plus is becoming as minus. Is that okay, Mahalakshmi? Clear? You just see here, I'll show you. So this entire thing, this entire term plus positive term is getting converted to going to the other side, no? So it becomes minus. R, T, L and Q, all of them are in the multiplication. So I am writing like that. Yeah, so let us go for the question. The equilibrium constant for the reaction was found to be 10 to the power 5. What is this? Equilibrium constant. So KEQ is equal to 10 to the power 5. And the temperature is 300 Kelvin. Find the standard Gibbs free energy for the reaction. Delta G R naught we have to find out. Okay. How will we get this? To find out the delta GR, we should know it is minus 2.303 into R into T log of KEQ, right? We have the value of KEQ, we have the value of temperature, and we all know that R is a gas constant. And what is the unit? I mean, what is the value for R here? In terms of joule per Kelvin per mole, it is 8.314. Okay. So 8.314 joule per Kelvin per mole. So this is the value of R. Okay. Universal gas constant value in terms of joule per Kelvin per mole. If you do not know this value before, please write down this value in your notebook. Please take down this value in your notebook. It is a constant value which you should know. So now try to substitute all the values. We have 2.303, R is 8.314, T is 300 into log of KEQ, which is 10 to the power 5. On substitution, we will get this step. Now, we can multiply these three numbers. But how will you solve this? Log 10 to the power 5. So log m to the power n is equal to n into log m. This is the mathematical formula. Okay. So now we have log of 10 to the power 5, which is equal to 5 into log 10. Log 10 is equal to 1. So 5 into 1 is 5. So what is the value of log 10 to the power 5? It is equal to 5. So in place of log 10 to the power 5, we can substitute 5. We know that log 10 is equal to 1. And if we multiply all these three values, we will get minus 5744.14 as the answer. And multiply that with the number 5 and you will arrive at this final number. Okay. So if you want to convert this value which is there in terms of joule to kilojoule, you have to move to the 3 decimal place, right? 1, 2 and 3. So that the answer you will get in terms of kilojoule, minus 28.720. So is it clear for all of you? Any doubt from this? Direct substitution. So here you have to spend your time for doing the multiplication. That's it. Okay. Otherwise it is going to be easier. If you know the formula and if you apply the formula and do the mathematics in that, you can get the answer. Nothing much to worry. Any doubt from this for anyone? Any doubt for anyone? Everything clear and okay from today's concept? So this is the end of this lesson. Let me summarize. So initially we have started with the entropy concept. Entropy is the randomness or disorderedness of a system, and it has one formula which is Q by T. And later on we have jumped into the Gibbs free energy, which has delta H minus T delta S as the formula. And delta G is the maximum work that can be extracted from any system. Okay. And also we have studied one formula from to find out the standard Gibbs free energy change of a reaction. Okay. So with this, the lesson gets over. Okay. So in the next class, we can solve the previous year's questions of NEET and JEE from the thermodynamics lesson. Okay. So what you have to do? So read and revise all the formulas which we have discussed in this lesson from the beginning till today's class. Okay. So that it will be very helpful for you to solve the questions in the next class. Okay. So if you do not study, then it is going to be very tough. Okay. So when I am solving, you will be blinking and sitting in your classrooms. Okay. You know how it has come and what is this, that kind of thing. So better you revise and come before you come for the next chemistry class. Okay. Any doubt? Do any of you have any doubt here? So before going out of this class, I have launched a poll for you regarding the class feedback. So all of you, please give your feedback over here and then you can leave the class. Okay. Thank you so much for listening. Thank you so much for attending the today's lecture. So we will all meet up with the set of questions from thermodynamics in the next session. Okay. Thank you. See you. Take care. Bye-bye. Thank you, Naveen Kumar. Thank you, Tanuja. Bye.